let's start. Did you have a good conference?
Yeah.
Great.
All pretty tired. Partying all night.
So, my name is Tommy Clark. I'm based in Sweden and been working with Lync for like 15 years since pretty much Exchange days and LCS and OCS and Lync. I'm an MVP for 4 years and I did the Masters rotation back in May last year.
So my name is Johan Delleman. I'm from Belgium. So we're both from Europe. Maybe you hear that we're not native speaking English. But anyway, I'm a 6 years Lync MVP and I did my master training in 2012 together with my buddy Gudmundur here. And today we're talking about meetings and media.
So we're going to start with the invites because it's a level 400 session, so you should all know about this, right? Great. So that's like the test to see that you fit into this room. And we have to have some slides with a snooper in. So thank you for coming. We know there's a lot of other good sessions. And
Okay, so this is our agenda slide. So we're going to talk about this. Probably you all know this from the workload poster. And the first thing you do if you look at this is like, okay, this looks easy, right? Yeah. Doesn't it? No, exactly. So it's not easy because everything is tied together in one slide. And it's like, maybe turn it down a little bit. Okay. So, and of course, if you just have one look, we don't know what's going on because so many lines, so many things at the same time. It doesn't move like it's just one picture. There's no animation in it. So we're going to try to explain a little bit better. Or we're not going to try, we're going to do it. But of course, we're not only going to talk about all those arrows on the slide, we're also going to talk about conferencing in general. For example, we are going to talk about the conferencing protocol because we're going to talk about what's going on under the hood as well in the conferencing. So what protocol is used, what servers, what components. So this is the first thing, and then we're going to look at the backend infrastructure. We are going to talk about the modalities because there are a lot of modalities, not only audio or video, there are some other things as well. And then, of course, life cycle is also an important one because, well, a conference will start sometime and it will stop sometime. And then if we have some time, we do have some extra slides because this is our repeat session and apparently we have 90 minutes instead of 75, so we have some more time. If you want to do more hardcore stuff and potentially if you have a lot of questions, that would be nice. So first of all, the conferencing protocol. Who knows this protocol? Let's show some hands if you know this. So not so many people, that's good. That's why we're here. We're going to explain it. So the conferencing protocol is called Centralized Conferencing Control Protocol. So it's called CCCP or C3P. You will see reference to both of those in documentation from Microsoft. So what is it actually, C3P? So it is a protocol Microsoft created, so it's not something general in the open. There's no RFC for it, except Microsoft specific, but they do publish all this information. So it's Microsoft created this stuff, and it's used to do creation, manipulation, and deleting of conferences. So it is an important protocol to understand if you want to do integration with Lync, for example, with other systems that want to integrate with Lync, for example, for video systems, they need to talk this protocol. Otherwise, they will not be able to join any meetings, and the Lync clients, well, it will be not a very nice experience. So it's important that all the systems understand this protocol. So the client is not speaking this protocol directly to the server. It is using SIP to send messages to the server, and it will embed this information in the SIP message. And of course, we use typical SIP messages like notify, service requests, stuff like that to send over all the information. And for example, bnotify is used to notify the user. For example, someone has joined the conference, and then we will add that to the roster. So 3CP is actually XML-based, and we will have, well, I have an example here. So this is a Snooper tool. I hope you all know Snooper. Because we're Lync guys, we all know Snooper, right? Because we have to do a lot of troubleshooting with it. So this is just a zip message. And you can see it, for example, here. So it's a start line, a service request. We will talk about it later, whatever happens here. But you see that at the end, it is talking to app.conf focus factory. So we're talking to the Lync backend infrastructure. And of course, in zip, we also say what is the content of this zip message. And we see clearly it's CCCP plus XML. So then we know this is a conference message. And of course, in the body, we will see this specific C3P message. So it's an XML-based message. And then there is always a command we are sending to the server and getting back. So there are many requests you can send to the server. For example, when we schedule a meeting, it's going to be add conference, of course. When we do some modifications, we change some options. It will be modifications, so modify conference. When we delete a message from our calendar, for example, it will be delete conference. Of course, we also need to get conference capabilities, because what are our capabilities of doing in meetings? Are we able to do video, for example? Are we able to do data conferencing? Can we do recording, stuff like that? And of course, we need to get a list of conferences as well. For example, can we get our static meeting? What are the configurations that go by that? And of course, there are other requests as well. For example, when a user joins a meeting, you will see add user. When a user leaves a meeting, it will be delete user. Of course, lobby access is also one of those, and conference log, for example. So those are all messages sent between the server and the client. So this one is for Tommy.
Yeah. So we're going to try to explain the focus and the focus factory a bit deeper. And the focus is managing conference state. So it's basically authenticated participants before allowing them to enter a meeting or a conference. And it's doing that based on the information that is stored in the in the conference database. And I will explain the database as well soon. So it's managing the conference state, like if someone locks the meeting, or if it's if you promote an attendee to a presenter or something. That's the focus responsibility to do that. We then have the focus factory, and that's a zip entity that creates and modifies the conference in the conference database. So when you schedule a meeting in Outlook, the Outlook client will talk to the focus factory to do that. And it will then create the meeting in the conference database and return back an URI for the meeting. So that's basically the link that you see in Outlook. We then have the MCU factory, or in some documentation it's also referred as the conference factory. And that one is responsible for provisioning the conference for a particular media type on a conference server, and that would be the MCU, so like the audio or video MCU. And now in Lync 2013, we don't have separate AV MCUs anymore, so everything is on the same box, right? But before with Lync 2010, it could be a different server role and so on. And then lastly, the conference database, that it's basically the RTC local database on the primary front end for that user that's trying to schedule the meeting. And it will then replicate all the replicates the data to the secondary servers via Windows Fabric. And the conference database only contains the metadata for the meeting. So there are some, if you do some settings or change some settings and change who is presenter, or if it's a muted conference and so on, that information will be stored in this database. But not the calendar information, because that's stored on the Exchange server. But we do store some information about timings, so when the meeting will expire and when it should activate and so on. So we're going to try to show this in a diagram. And to start with, we have the conferencing client. That would be Lync in this case, for this scenario. And the scheduling client would be the Outlook with the Lync add-on installed. So when you schedule a meeting, Outlook will talk to the Focus Factory to create that meeting and get back the URI. And it's actually in this state where the Focus Factory talks to the backend and store that information over there, and then returns the meeting information to the client. At the next, so this is basically scheduling only before we start or activate the meeting. And when we then join the meeting or click the join button in Lync, the conferencing client will talk to the Focus, and the Focus will then ask the backend database if this user is a presenter or an attendee, if he should be locked in the lobby or get access into the meeting directly. But before starting the conference, the Focus will also talk to the conferencing MCU and just contact the conferencing factory and ask where it should start the meeting. So let's say you have a front-end pool with 5 servers, and I'm located, my primary server is server 1, and the backups are 2 and 3. If server 1 is very busy with other meetings, so let's say it's a meeting with 150 participants in that one, and there's nothing really going on server 2 or 3 or something, the conferencing MCU and the conferencing server could actually start that meeting on a different server where nothing is going on, and it will decide on this on this stage. When that's decided, the Focus will start the meeting on the MCU that it's been decided on, and at the last stage here, the conferencing client just connects to that MCU and the meeting is going on. We will try to explain this a little bit more later on in a demo to show what's really happening, but this is the start of it. We also have this slide to show kind of what protocol and how everything talks to each other. And we can see that it says UCMA 4.0 down, but that's basically the Lync client as well. And it's, yeah, the Focus talks to all these MCUs with C3P over HTTPS. And we have a question.
Yeah, actually, a question. I didn't know that if the server was busy, it might actually start it on a different front end. I always thought it always started on primary.
Yeah.
So that's interesting. Does it, I mean, do you have multiple modalities of conference? Could they just put across different front ends? Or can you start an instant message conference on one and then audio video on another, or is it always on one?
That's a good question. That's like a Skype ticket question.
So we assume it'll always be the same server, because we haven't seen it in reality doing multiple servers for one conference. So I think it's only one server.
I think it's going to keep all.
Yeah.
Starting NFC.
But I kind of heard that it could. I heard that it could, but I'm not sure about that, and we haven't really been able to test it. So, yeah. That's why we assume that everything will be stored on one server. But when we look at the invites, you can see an invite going on to, we see like 3 different invites going on when we start a meeting, and that could be, so it's theoretically possible, but we believe it's all going on one server.
So next, we're going to talk about modalities, and obviously there are many modalities, like instant messaging, audio, video, app sharing, and web conferencing. So we will go through all of those, and it's like we will talk about them separately and have a same kind of build-up. We talk about the same stuff for every modality. So instant messaging, audio, mixing. So the brackets, mixing is very important. Because if you look at video, it's switching. So there's a big difference between these two. And you will see why. Application sharing and web conferencing. And then again, we are all PowerShell guys. So if we want to get the status of all of these modalities, then we just can say get CS Windows Service. And then we filter on MCU. Then we will see the state and also the activity levels. So that's quite interesting.
That's like the best way of seeing the activity level on the different front ends. You could also do a remote PowerShell to all your front-end servers in the pool and see what's going on the different servers.
So let's start with IAM conferencing server, which is taking care of IAM conferencing. So it's still, well, it's SIP as a transport, so we're not doing any media streams because it's just signaling to the server back and forth. And what is it called? So the service itself is RTC IAM MCU. Makes sense, right? So there's a separate service for the IAM conferencing. And this is the XZ. And of course, we can drill down into that specific service. So we just say get CS Windows Service and the name RTC IAM MCU, and we get the results. So we're going to try to look at features and what default value and what things you can configure on a specific modality. Like, for example, will IAM start automatically? Yes or no? Default is no. In Lync 2013, we just join a meeting and it will be audio. So if you want to do IAM as well, then you open the IAM tab and start IAMing. Then secondly is, can IAM be disabled? Yes, we know. Because of the latest updates, Microsoft added some interesting feature, disable IAM in a meeting, which is very, very good because it's kind of annoying if you have a large meeting and then having all those pop-ups for all messages going on. So it's a meeting setting. What does that mean? It's when we schedule it, we can tweak the configuration to disable IAM. So what else can we do? For example, Q&A. Q&A is also a way to disable IAM because you will only be able to ask questions and not to type IAM messages. So presenters need to answer those questions. Can we do an IAM-only meeting? That was a question I wanted to answer myself because I did some testing and I was wondering, can we do that? And I know in Lync 2010 I couldn't do it. And I was a little bit surprised to see that you can do it in Lync 2030. So if you disable allow IP audio, you will have an IAM-only meeting. So that's kind of interesting. Because I had a customer in Lync 2010 timeframe, he wanted to do IAM-only meetings. And I tested it, didn't work. And they had to do group chat, which is not so interesting. So you can do IAM-only meetings. So how do you configure this? So like I said, at scheduling time, you just select the meeting options and you say disable IAM. Of course, you can also add allow Q&A. And then if you do this, you will have this experience when you join a meeting. So the presenter has disabled IAM capabilities. How do we enable Q&A? Q&A, we cannot schedule a meeting Q&A ready. You have to join the meeting as a presenter and then enable Q&A. So you go to your client and select the option enable Q&A, and this is what the users see. So they can ask questions. So they don't have an IAM window, but they can still ask questions. So then we move on to how does it all work under the covers? So how do we connect to a meeting for IAM? So we told you it's a SIP message, so it's still SIP signaling. So we see here we do a SIP invite. So we do a SIP invite to the chat MCU, because we see at the end it's conf chat ID and then the meeting. So we are actually talking to the IAM MCU with that specific meeting. So we invite it, so we want to join it. So it's from the user to the MCU. And then we look at the content type. So the content type is SDP. Does anyone know what SDP is? Or does everyone know what SDP is? Session Description Protocol. Okay. It's kind of weird because it's used in media. And IAM is not really media. But still, it's an invite. We have to do some SDP. And we say in the media type, it's message. We say message, and usually when you do negotiations for audio, you put in IP addresses and ports, all of those things, which we will see in audio. But effectively, we have an empty SDP message with only specifying this is an IAM. So this is the way to join an IAM conference.
Question. It says 5060. Does that mean it's not encrypted?
Well, I don't think they use the port.
I don't think that's the port either.
Well, it might be like coming from RFC, and they don't even bother because the port is not important. They don't change it. I didn't actually notice it. But anyway, we would be signaling, normally you would be able to see, well, if you do tracing on the server side, you would see the ports. So, but this is done from the client, so I cannot see the server ports, but you will see it's 5061. So, and then what is happening when we're sending an IAM? So it's just a message. So we send a message, so a SIP message, which is message. And then we say, okay, this is the content type, and it will be, the body will be the IAM. Of course, you cannot see it in Snooper because it's not too important for troubleshooting. So that's it for IAM conferencing. Any questions? So next we talk about audio-video conferencing. A little bit more complex because lots of stuff going on there. So we start with, like we did for IAM, we go over the basic stuff first. So it's RTC AV MCU, audio and video. Of course, again, another service. And of course, we can also check what is the activity level for that specific service. So, and then we go to the feature list, like how to start audio in a meeting. Yeah, of course, we know audio always starts. That's the default configuration, unless we don't have it allowed. Can it be disabled? Of course, it can be disabled. We disable the allow IP audio. We set it to false, and you will not be able to organize a meeting with audio. So you configure this in a conference policy. So this is on the Lync server backend. So and you can say these users cannot schedule audio meetings. Those users can do it. So you can mix and match. Can we have IP-only, audio-only meetings? Yes, of course, if we disable all the rest, like video, IAM, desktop sharing, and data collaboration. Let's see what else important here. Can we mute, of course, a single participant, all participants? Can we disable video? Of course, we also have that setting, allow IP video, like we have allow IP audio. And then can we have video-only meetings? That would be very hard because you always need the audio part. We got a question last time, like, okay, if you're doing sign language, would you need audio? But then you would not be sending any media because then it's just not sending the data. So how do we disable audio video? So here we have those policies, allow IP audio, IP video. We can set them to false. And then if you do that, then it removes, because this is an invite with these settings enabled, and it will remove everything for dial-in conferencing as well. So it will remove all the dial-in numbers. So you will see like an Office 365-like invite or invitation. And then if you join, this is what you get. Or you could also start a meeting and decide not to join the audio part. You could also do that. And of course, muting audio and video, we have the options at scheduling time. So to mute all the participants and block video. But if we just start up a meeting and we decide to do it during the meeting, we can also do that, because we have the knobs to do it mute audience and no audio and video. So let's look at some conferencing policies here. So we already know about IP audio, IP video, but allow multi-view. So allow multi-view and the one underneath enable multi-view join. They're very different, because one is an organizer policy, one is a user policy. So for a user to organize a multi-view meeting, you must have this capability. And then, for example, if you have a multi-view conference, but you want to specify some people, maybe from the branch, not to do multi-video, then you can do that. Also important here is if you want to tweak like how much data is being sent over the wire, we can also do that. The max video conference resolution is actually a setting from Lync 2010. It's not used any longer because we have so many more resolutions, because VGA and HD, that doesn't make any sense in 2013. So we can tweak the audio bitrate, which is by default 200. And if you look at total received video bitrate, it's 50 megabits per second. So by default, so that's a lot. So if you want to tweak that, you can do that, and it's per user. But it really means what is the total received bandwidth. So it means from all your video streams you are viewing. And then the other one is actually whatever you are sending to the conference. So the video bitrate, also default 50,000.
Sorry, what will happen on the client side if they achieve that, once they hit that threshold?
50,000?
Well, you said
Oh.
what was it?
Well, they will not use the, well, they will switch to another codec or lower resolution. It's like, call it mission control, but then fixed. So call it mission control is then variable, and this is fixed. So let's look at the details. So I said audio mixing. So speakers are talking to the conferencing server, and we mix up to 5 streams, and we send it back to the client. And it's important that we mix, because we need to mix all the speakers into the same stream, because we cannot have multiple streams of audio. So and then we look at whatever is happening at the server side, because potentially clients can send any kind of codec compatible for conferencing. So for example, a client is using G722, which is a default codec for conferencing, to the server, for example, or when he's listening and he's sending some other codec. This is potentially when you have an asynchronous communication or network like ADSL, if you don't have enough bandwidth from one side to the other, so you potentially can have different codecs. But the important I want to stress here is that the server takes many different codecs and it will mix them together. So for example, the room system will use the stereo codec, and then dial-in conferencing will use G711. So we see a lot of different codecs here, and the server will do mixing. So and this is another graphical interpretation how this works. So we have all those streams, all these different streams, so the speakers are talking into the conference, and that's up to 5 active speakers. But we are going to have to decode these, because we are going to mix them together, because we cannot mix all the different codecs just together. So, and that means we have CPU cycles, of course, then we mix, and then we have to send out all the streams again. And of course, if you are talking to a conference, then you don't hear yourself talk. So the conferencing server also needs to exclude this stream from the stream you're receiving. So there's a lot going on here. So re-encoding and then sending it. So you understand there's a little bit more CPU processing required. So then we drill a little bit more down, like in the codecs. So this comes from MSDN. So this is not the complete list, because I will show you a little bit later what is the complete list the client will be sending and the server. So, but an important thing to say here, clock rates. You all know about the clock rates. So narrowband, wideband. So the narrowband codecs are 8,000 hertz, and the wideband 16,000 hertz. And then you can also look at P times. For example, how many samples per second are we going to do and how much time in between we can, so those are milliseconds. So, and you will see, for example, if you have a high latency link, you will use Siren instead of G722 because it can go up to 200 milliseconds to do the sampling. And when I wanted to do my demo, I wanted to see it switch from G722 to Siren, but because my servers are in Europe, I'm already using Siren. It's kind of difficult to show that. So this is the SDP list of codecs when you invite the audio conference. Or just do a peer-to-peer session, so it's the same. So the client will always send the same codecs to the server. So if you know about SDP, you know that the preference is in going with the order. So it's from left to right. So we prefer codec 117 above 114, above 104, and so on. So the preference is important here. And of course, all the codecs are listed underneath. But when I was doing the session, preparing the session, I saw that maybe there's some strange information in here because we prefer actually the G722 8000 sampling stereo codec. So, but why would we send an 8000 sampling codec as the preferred codec? Because we don't want to use narrowband, do we? So I was wondering, could this be a mistake? Do you know? Does anyone know, for example? Because I did some digging around and I found some interesting stuff. Like G722 8000 Hertz is actually not correct. Someone made a mistake when the RFC was created, and it's actually a wideband codec, but it's written like it seems to be a narrowband codec. So it is correct. So we know it's 16,000 Hertz sampling, but it needs to be, we cannot change the name because it's an RFC. We need to be backward compatible, so it stays in there. Okay, we have to live with it, but now we know it's a wideband codec, so we don't have to worry. So then we know, okay, the first parts are all wideband codecs, and then the others are narrowband codecs. Of course, we see some other stuff in here. XMSRTA, that's of course RT Audio from Microsoft, also wideband, narrowband. And then Silk, you all know Silk probably, because you've seen the sessions from Skype, so that's the Skype codec. And it's in there for a longer time. I don't really know from which cumulative update it's in there, but it's in there for a longer time. And then we have Red is a redundant codec. And of course, we have the PCMU, PCMA, which is G711. So now we talk about joining the conference. Again, this is very similar, like joining an IM, because we send an invite to the conference MCU, so the audio-video conference. Then we, of course, we see that this is an SDP message, and we see that media is audio, and then the next slide we see the list of codecs, the list of IP addresses, the list of ports being used. So this is the list of codecs, so the preferred order, and then they're all listed down there. So then if you look at, okay, the client is sending an SDP offer, whatever is the server sending. So if you look what the server is sending, it's a smaller list of codecs. So we actually have to, well, these codecs in red, they will not be used. And there's a very good reason. It might be a little bit strange why the RT audio codec is not preferred or not used in conferences, but it's actually not a very CPU-friendly codec. It's a very, very intelligent codec, but it's not, well, it's not really suited for conferencing. So all the other codecs, they are far better for conferencing because we have to do the re-encoding and decoding. So if you then look at the re-invite, because usually between, I think it's 5 or 10 seconds, we see a re-invite, and then you will see whatever is, okay, we will see this is audio, and we have the codecs all listed here. And of course, we can see the final candidates if you want to troubleshoot. I do this a lot. to see whatever ports and IP addresses we are using. And then we have the remote candidates as well, and all the codecs over here. So if you look at, then we put everything together, so we know we talked about this already. And then we said in the reinvite, we actually see that the first codec is not used. So it's fallen out of the final invite. So this is actually the stereo codec used by Lync Room system. And actually it's not, the Lync client would not use this codec, because how would you do stereo mics on a laptop or a single device? So it's left out from the reinvite. So this is actually the complete list of codecs that we are going to use on the Lync client. So and then we see, of course, that G722 8000 is the preferred codec. And then we can fall back to Siren. And of course, G711 we have to use for dialing conferencing.
Do we want to expand on that room system thing with the registry settings and enablement?
Yeah, apparently I talked to Roy Kuntz, Anton Krantz, because he was the guy doing Lync Room systems, and I wanted to have a little bit more information about the stereo codec. So he says that in order to do the stereo codec, you have to do some specific registry key entries to enable the stereo codec. So potentially the Lync client would be able to do it, but yeah, would it make sense because you're sending more information, because you're trying to do stereo, which you can't.
We don't want to have like large meeting rooms with microphone arrays might not be suited for stereo audio as well. So it's kind of depending on how you set up your room, you would enable that for per room.
Would you use that on the CX5 5X range? Would that use take that stereo noise, right?
I didn't catch the question.
With a Polycom 6 5000 or 5000 whatever, they can have a stereo mic.
Yeah, so you would probably use it then, I guess.
Don't know about that, but probably you could ask the Polycom guys, because they will know that.
Yeah.
Even long-term. What would SILC be used outside of the spec, like a full pure near stereo? Would SILC ever be preferred of RC audio?
Well, it's in there, so they can use it. It's not preferred currently, so if it moves up, then it will be preferred.
Okay, so it moves up by a very simple thing.
No, you cannot change.
Well, I mean, we link SILC over RC audio experience. So it seems to be a little better for like a home user sometimes on bad network.
Well, I'm not sure if they are talking about it in the Lync Skype V2 session. Was anyone in that session? And did they talk about Silk? Okay, I haven't seen it, so. But then look at the recordings for that session, and I'll probably have some more information. So then in order to get whatever you are using during a conference, you want to view what codec is being used. So of course we use Network Monitor, because we're in a Lync Conference, and it's a Microsoft tool. And it's very, very good, because I like it, because you can see specifically which XZ is sending information to what IP address. I use it a lot, actually. So if you then look at the UDP streams, because media is UDP, then we're trying to find out what codec are we using. So I found that if you're internally, then it will say RTP, and then you will see directly what codec you are using. But if you're talking to the edge, it will display as UDP. And then you have to decode before you can see what codec is used. So the one selected on the right, so this is the codec. So you have to figure out yourself, what the hell is this? But you can do select and then decode as, and then it will show you what codec it is. So you see it, it's G722, 8000. So now we move into what are the streams going on. So for example, if we join a conference, potentially we are clicking the link, and then we go to the reverse proxy, right, on 443. And remember, we need to bridge to 4443 to the backend. And internally, it will just connect to 443. Then, of course, we will signal to the access proxy, access edge, on 443, of course. And then Edge and Lync server will talk 5061. And internally, we'll use 5061. Then, of course, we are going to send, so the external client is going to send to port 3478, because we want, and it's UDP, because media, we want to use UDP because it's more performant. So we will use this port, and then the media flow. So we all know that Edge will not send or create a connection to the conferencing server, because ICE is doing all the firewall stuff behind, because we're not explaining the firewall rules here. This is only what ports are used. So the media is flowing from Edge, and it will send it to the port range on the MCU. So this port range is a big port range, more than 8,000 ports. So it's 49152 until 57500. So this is the port range. You can customize it if you want. Usually I don't do that because it's scaled to host so many users. So it's better to leave it this way, because otherwise you have to do other scale scenarios. Then, of course, the server will also be sending a stream. So we have 2 streams going both sides. And then the server will send to UDP 3478 to Edge. And the source port will actually be also in that high port range on the server side. I actually got a question last time, like, do we also need to have access to the high port range on Edge from internal? So and we don't need to have access to that port range, because we're actually using just tunneling to the 3478 port, and then the server does whatever magic he needs to do in order to bridge us to the high port range on the external side. So we just only need access to 3478 UDP. And then the Edge server will send the media traffic to the client, and default port range on the client is 60,000 ports. It goes from 1024 until the upper port range. So this is default configuration, which usually we change in deployments, because 64K ports, kind of very much. And of course, internally, we're also going to send to the high port range on the server, and then, of course, the 64K port range on the client. And then, in case there is dialing conferencing in the mix, of course, these are both audio servers, as well the MCU as the mediation server, and they use exactly the same port range. So we will use these both 8,000 port ranges. So what happens if we add Lync mobile clients to the mix? Of course, we all know that signaling will go to the reverse proxy on 443, and that the internal mobile clients actually also need to go to the outside and go into the reverse proxy. So they will signal 4443, of course, to the server backend. And then media is essentially the same as we did with the normal client. So any questions here? So I did a good job explaining. Thank you.
Yeah, thank you for the report for this.
Okay, I have some other slides if you're interested at the end of the session. I can do, I have listed all the ports and how you can customize them.
Question?
Oh.
In previous slide, from the edge to the outside, there is a huge range of UDP ports. Is it necessary for the new clients, or it's necessary for the old clients or OCS servers? From edge to Lync web app, UDP 1024 hash SRTP. Is it necessary for it, or for the backup to the old clients?
Well, the web app uses the control you have to install when you join the meetings, and it's essentially a media stack. It just behaves the same way as a Lync client. Does that answer your question? Okay. So then we dive into video details. So video is completely different from audio. So we can have up to 5 streams we are viewing in a multi-view video conference. And video is switched. So we are not going to do mixing, because I would need huge CPU power. Of course, we all know that H.264 SVC is the default codec now, and that the old codec, H.263, do you all know H.263? This is the codec OCS used in the early days, so it's a very small resolution codec, so we don't support it anymore. It used to be, like, if you want to do interop with video systems, then this would be the codec you potentially could use to connect to, for example, Tandberg in the early days. So, but it's not longer there, so this is not possible anymore. And of course, RTVC1 is RT video, and it's still, well, it's considered a legacy codec, and we prefer not to use it because 264 is far better for video. So if you look at the SDP and offers for video, we will only see 3 codecs. So the first one, of course, is the default one, 264 AVC SVC. And then the second one would be RT video. Then the last one is actually forward error correction codec, which also needs to be in there. Well, it's the same like in audio. You can send extra packets. Also, this codec will be used if you have a bad network connection, for example. So then we look at video switching. What does it actually mean? So we see a lot of streams going on. And if you want to know more about this, Jeff from Polycom, he has a really excellent session about this. But still, I'm going to explain it a little bit. But if you want to know more, definitely go look at that session. So we know that if we had a multi-video view, then we are receiving 5 streams, right? We are only sending our stream if no one is requesting other resolution. So at this time, we are only sending 1 stream, and we are receiving the 5 streams. Apart from the other 2 on the left, because they probably have the setting, don't join multi-video view. So they are only receiving the small window size and only 1 stream. So, but for example, if they go to full screen and the Lync room system is the active speaker, he will need to send an extra stream to those participants because this resolution is not yet available in the conference MCU. So he's going to request it from the client. Hey, client, send me another resolution because someone is requesting that. So we're going to add another stream. So Lync room system at this stage is sending 2 streams, one the normal resolution and then the higher resolution. So, and if you look at all the different things here, so on the left side we see a lot of streams coming into the video MCU, and then of course only the streams required for our client are going to be sent to our client. So essentially we're going to send 240p because we're just joined via the normal window, and then we see the 5 videos. So if we then add content to that, of course we are going to request smaller video streams. So this will be 1080p. No, 180p. Excuse me. The big difference. Of course, if we then move to active speaker view, again, we're just going to request 1 or potentially 2 for previous active speaker. And then, of course, if we go full screen, we only request the full screen resolution. This slide I want to emphasize on rate matching because there's not only going, resolution is not the only important thing here. Rate matching is like if you don't have the right bandwidth or capabilities, then potentially we scale down the frames per second. So for example, we are sending 180p to a potential other client, and the first client might be able to receive 30 frames per second, and the second client says, my network is not very good, only send me 15, or potentially 7.5 frames per second. So and of course, if we are having other streams, they will also go through the server, and the same thing can happen to all the streams. No questions?
For troubleshooting, how do we detect that, what frame rate you're getting?
Well, that's a difficult one, I think. I'm not sure you potentially could see it in a network monitor, but you would need to dig in very, very deep. I know you can see like the resolutions will be in the monitoring report, but I don't think you will see like frames per second. Not sure. So no decoding, mixing, re-encoding. So the difference audio, video. And of course, joining the conference, again, a SIP message. We send an invite to the audio-video MCU with a specific conference ID. And again, we send the SDPs, like the M is for video, so we're going to add video, and these are the codecs. So let's look at the port ranges we are using for video. It's very similar to audio, but there's a little difference. So again, I'm not drawing all the other arrows because the process is essentially the same. So the client is again sending UDP to the edge server from external on 3478. And then again, the edge server will be sending that stream to the server on a different port range because audio and video are not on the same port range. Because video starts at 57501 until the upper port range. So that's also default configuration. And then again, the server will send, so the MCU will send to the edge server 3478 UDP and send to the 60K port range. And the same thing for the internal client. So sending to the video port range on the server side and then the 64K port range by default. So we're all good? Okay, let's move on. Application sharing. So this is the RTC AS application sharing MCU. Again, different service. And again, we can request the information about activities. So app sharing, does it start automatically, for example? Well, we all know that's not true, but the viewing starts automatically when you join a conference. Can it be disabled? Yeah, of course. We have policies. We have conferencing policies to do that. Can we have app sharing only meeting? Of course. We cannot have that, but if you expand from IAM and add application sharing, that would work, of course. But then you still have IAM. So how do we do desktop application sharing? Of course, we select this. And what codecs will be used? So shared desktop or application, the codec being used is RDP. So, and it's still a media stream. So, but the RDP will have RDP inside. So if you look at the SDP and offers, we will see that there's only one codec, 127, and it's the X-Data codec, whichever Microsoft specified. And you see at the bottom, media type is RDP. And again, if you add application sharing, it's again the same thing. We send an invite to the application sharing server or MCU. And again, we have the SDPs, and we see that M, the media type, is application sharing. And again, all the IPs and port ranges. And of course, the codec in here. So how can we configure this on the server side or on the client side? So we can disable it. So we can disable a user from creating meetings with application sharing, because application sharing is essentially something you may not want always, because RDP is like spiky, and it might send a lot of data through your network, because you cannot really control it, also not by CAG, call it mission control. So, for example, you may want to limit the amount of data being sent. Like if you have the last option there, app sharing bitrate, you can specify or you can lower the amount of data people will be sending and receiving. So if you look at app sharing, again, it's essentially the same as audio and video, except for a little bit difference on the server side. So we are adding application sharing. So again, the client will be sending, well, at this time it's not UDP. We are going to do TCP because it's TCP-based. RDP in Lync is still TCP. So we're going to send it to 443 on the edge server side. And then the flow will be from the MCU to the edge server. And you will see that we are also going to use 443 on the edge side, but the source port range is 49152 until the upper port range. So this actually means that audio and video and application sharing are using the same port. So application sharing uses both audio and video port ranges. So there are like 16,000 ports available for application sharing. And this is potentially you want to change. Because if you want to do call admission quality of service, for example, you want to change it because it makes life a little bit difficult if you leave it default. So you want to change it. I have some slides at the end I can show. So, and one important thing here to show is that there are not two streams, because this is TCP-based session, so the streams will go back and forth in a single stream. But if you do this federated, it is a little bit different. So again, on the server side, to edge, it's the same. But if we go to the federated Lync client or Lync server, we are going to send to 443 on the edge, the foreign edge side, but our source ports are very different. Our source ports need to be the high port ranges on the edge, outgoing. So this is the only way you need those high port ranges on edge for federated application sharing and file sharing, of course, as well.
And there are some advantages to opening that port range, both inbound and outbound. Even though we don't have to open it up inbound anymore, right? You want to expand on that a little bit?
Yeah, I think there's a media path optimization if you open them inbound. I think it's related to if you want to do hybrid with Office 365. The media streams can potentially, so the federated client can then go directly to your edge instead of going to his edge and then bridging to your edge and going to the client. So if one is sitting in, well, if you're sitting in different continents or your servers are sitting in different continents, you will always have to do hairpinning. And potentially you can, if you move, well, if you are visiting, for example, Europe and the other party is Europe-based, then you will directly send your media to the Europe server for the other company instead of going to your server in US, for example. So that's
and it's also good for larger deployments where you have like 50,000 users plus. So it's not going to use as much resources on the edge servers if you open up those port ranges. Yeah.
So and the internal clients, of course, will send to the server ports. And then the last piece is web conferencing, which is funny enough called data MCU. So it's not web MCU, it's data MCU. Again, different service, and you can request the activity levels. So how to start web conferencing. Can we disable it? Yes, of course, we can disable data conferencing in the conferencing policy. Can we have web conference only meetings? Of course not. Here we have the configuration. Do we enable it, yes or no? So it's a conference policy. And then all the other stuff like, do we allow annotations? Can we record? Can we do Q&A? All of this stuff. So one important thing, and this is a little bit different from all the other modalities, is that we all know that there's a separate edge role. So the how's it called, conferencing edge server or component. And it's a little bit different than all the media streams. So whenever a front end, which is essentially the MCU, starts up, it will create a persistent connection to the edge. And it will do that at startup. So this is the message you will see in the event log. So the server, so the MCU will connect to the edge on port 8057. And it does that at startup. And there's only one connection. It will be shared by all sessions. So if you then, for example, add a whiteboard to our conference, we know that the server started and it has connected to the edge with that specific port, so, and this session stays open all the time. Then, of course, a client will send TCP 443 to the conferencing edge. And then internally is exactly the same, connecting to 8057. Any questions? Okay. Then, of course, PowerPoint, which is not really media. We all know that it goes to the reverse proxy, also for the mobile client. And then, of course, we go 443 directly, not 4443, but just 443 to the Office Web Apps form. And internally, we just connect directly to the Office Web Apps form.
One funny thing that we find out regarding PowerPoint sharing is that the annotation is kind of overlaid over the PowerPoint presentation. So if you share a PowerPoint, it will be rendered from the Office Web App server, but if you do an annotation, that will be kind of whiteboarded over the PowerPoint somehow. Okay.
So next section is conference lifecycle.
Yeah. So this will just be a kind of a recap from how we scheduled the meeting and the focus that I explained at the beginning. And well, we have Outlook. We talk to the Focus Factory, and the Focus Factory schedules the meeting and sends back the meeting information with a 200 OK. And you have to remember that 200 OK for the last slide then. And what we also found out was that we can actually schedule kind of offline meetings. So if you're sitting on the airplane, you can schedule a meeting. And how does that contradict with it? Because we are actually talking to the Focus Factory live here, right? But if we have like the default meeting setting on, it's on this slide, I think, here. So if we have assigned conference type by default enabled to true, that actually means that we will always have our default meeting ID to the same ID. So you can like have meetings that are, if you schedule a meeting at 10 and then you have the next default meeting at 11 and people starting to join those, it's going to be the same meeting, right? And if you upload files, it's going to stay inside that meeting. And so it's kind of usual that you turn that feature off. But that would also mean that you can't schedule these offline meetings. The default in on-prem is that it's enabled. So the default setting is true, and the default setting in online is actually false. So we don't have any default meeting in Lync Online. But you can change this in both Lync Online and on-prem. And it's the same setting, but you have to add the tenant ID to when you do it in Lync Online. And if we check the register settings, we have this public meeting reg key if we are enabled for this default meeting. So this is Johan's client, and he have the on-prem settings enabled, so he could schedule that default meeting here. And if I check on my client as Lync Online, I don't have this red key, so I can't do it. And my Lync client will say, like, hey, you have to connect before scheduling a meeting. And so this is no cache, and that would be an online non-default meeting then. And we send a service request with the get conference capabilities over a C3P message to the server, and get back at 200 OK. And oh, this is the static meeting. So this is the default meeting then.
Yeah.
And then we get back the meeting ID, and we can start the meeting from there.
Yeah, so essentially the second step is, so the first step is get conference capabilities. So what can we do in a conference? And then the second one is, what is my static meeting? Give me my static meeting settings, and then you get them back. And then you get all the information in the last step. But we have some snooper logs to show you.
And this is when we schedule a custom meeting. So you see that it's a bit different here. And you actually see that if you just slide through both slides back and forward, it's going to be more clear to see what the difference are. But we add a conference and then send a C3P message to get conference ID, and do we want to show this in the demo? So this is basically the service request, and we see the add conference C3P message over there.
So essentially, this is a trace for scheduling a default conference, so not cached in Outlook, so you effectively connect to the server. So to see, the first one is actually, it sends a service message to the Focus Factory, and it says, get my conferencing capabilities. So then you get a response from the server, like these are all the conferencing capabilities. So these MCUs are available to be used. This is the dial-in information. And this is, for example, do we allow anonymous meetings? Does PSTN need to be in the lobby, yes or no? So this is this information.
And this is also like the best way or only way to know what Lync Online does, because it's not really documented so deeply. But if you check your client logs in Snooper, you're going to see all the different settings that Lync Online sends back to your client. So all the kind of policies and the default values that you have, not only for the meetings, but for every policy.
So and then the second one is, it's requesting get me the conference or get me my conferences, the static one to true. So get me my static conference information. So and then you get back this information because you get, for example, the conference ID. Because you request what is my static information, you get back the ID, and then you will send get conference, and of course you say with the ID, and then you will get all the information about your static conference. So that's essentially the flow to schedule a default meeting. So
because it's a default meeting, it won't write a new meeting to the database. So that's the same meeting all the time, unless you go into the web client and request a new meeting ID.
Yeah. So the second sample here is when we are doing a custom meeting. So we are changing some options in the meeting dialog. So then essentially we are going to do add conference because we are going to create a new one. We didn't have to do it in the static because it already existed, so we just request it. So we say add conference, and then we get back the information in here. Then we say get the conference for, and then whatever we added as the conference. So then we get this information. And then, for example, this one, I modified some stuff on the invite. When doing in Outlook the invitation, you change some options there. Then you will see modified conference. Then you will send that to the server. So let's go check on the server side. So not sure, does anyone know AP DB Analyzer? So it's a tool from the resource kit which you can dig into the database on a supported way. Well, resource kit is not always supported, but it's like you don't want to touch the database, right? So you use this tool to get a report. For example, this first report. So if you run this command, it will generate a report for the user. What did it do?
Control Z.
I deleted it.
Again. Control Z.
Okay. Okay. Accidentally deleted it. So if you run this command, it's essentially connecting to the database, so the RTC local database, and you say, give me a report for the user. And a report for the user is actually very big because it has everything in there, like your contact lists, your settings, your conferences as well, your certificates. All of this is returned. And one of those things returned is the conferences you have organized. So they're listed here. So then you can see what conferences have I organized and which one is the static one. Because we can see here, this is the static meeting, so it's very visible. Then we can do another query, for example, this one. And this one actually goes to get a report, not a user report, but a conferencing report. Because we specify conference here, and then we specify the conference ID. Then we can get some information about this conference. So you see, this is the information retrieved from the command, and then you will see, like, for example, organizer data. When did we provision this meeting? You can see it here. When did we provision this meeting? And then when will it expire? Because we will also talk about the conference lifecycle, also talks about scheduling, but also about, well, deleting a conference and expiring a conference.
Was this the full day meeting, right? So this one was a full day meeting and not scheduled for like an hour or something, and that's why we see the 12 a.m. time frame. So it's the expiration time is 15 days from when the meeting are supposed to start.
So we switch back.
Does that mean the lobby exists for all that time? Or is the lobby gone away?
It could be the reason, yeah.
Well, once a conference is scheduled, it doesn't matter what time you scheduled it, it will automatically be there, because you can join it anyway right from then. So the lobby is there.
Good reason not to use the same
Yeah,
ID
absolutely.
over and over again.
So if you want to have security, you don't use the default meeting IDs.
But you can't schedule offline meetings.
You're on the airplane, right? Get over it, put the computer away.
Yeah, kind of. So here's the recap of what we just saw. And we do see the conference IDs. And that's like all your meeting that you have scheduled, both in Outlook or in the web scheduler. So let's say your organization doesn't use Exchange. Then you have to use the web scheduler to schedule those kind of meetings. And we can't really delete meetings. So if you schedule a meeting in the web scheduler, you have to log on to the web scheduler to delete that meeting. And if you schedule a meeting from Outlook, you have to delete it from there. And we also see the PSTN IDs for these kind of meetings in here. We covered this. Okay, so conference activation. So at the first part, we just scheduled the meeting. So it's active in the database, or actually it was inactive. It's not active yet. And I didn't maybe notice that the MCU status said inactive. But when we first log on or click the join meeting link, we're going to activate the meeting. And from that time, it will be active for until you click the end meeting button.
So this is an example of starting an ad hoc meeting. Like the first thing we do if we start an ad hoc meeting is, of course, we have to add a conference because it's always another conference ID. So it sends a service message to the Focus Factory with a conference ID. And then, of course, we're automatically going to join it. So we send an invite to the Focus. So we're going to join that meeting. And then, of course, we're also going to subscribe to the Focus because we want to receive updates, whatever is happening in that meeting. And then, obviously, we're going to, for example, invite the chat MCU, and then we're going to invite the AV MCU. Other stuff going on the server side is there will also be joining guests. So it's actually a conference announcement service, which essentially has the name of the user, and it puts guests in front of that. You will see that in Snooper. So the conferencing announcement service actually also joins that meeting. And it also subscribes to that meeting to obviously announce whoever is joining in that meeting. So that's an example flow, for example.
So, and before I kind of understand these different MCUs and stuff, I was always curious why we always saw like 3 invites for every meeting. But that's because we invite different MCUs. And this could potentially be different MCUs and different servers, but as we talked about earlier. But in the testing, we only see like 1 server. So.
Well, and the last part is actually, if you look at number 10, it's actually another user joining, and then you get an info message like every participant gets this info message like another user has joined. So then you update the roster list and potentially also the capabilities like if someone is joined via IAM only, or did he join the audio piece, or did he follow the desktop session, for example.
Okay, so deactivation. After we joined the meeting and started the meeting, we want to deactivate the meeting. And that's going to happen when all the enterprise users leave the meeting. And if you just click the exit button in the top corner, or if you have a bad network connection and gets kicked out, the meeting won't be deactivated, right? But if you go in and click end meeting, all the participants will be kicked out and at that time frame. But if you just close it down, the anonymously joined users will not be kicked out after until 90 minutes. And that time frame was like 10 minutes before or something, but the default value now is 90 minutes. And
can we change that value?
yeah.
Yeah, we have another slide which shows that.
So when you end the meeting, it will apparently end, and it will also send a delete conference to the Focus Factory that will start some maintenance and remove like files and stuff that you have uploaded. But it is possible to join the meeting before it's fully deleted from the server. If someone comes up to you and asks, like, how do I delete everything from this meeting? Like the CIO had a meeting with a presentation and uploaded files and so on. It's important that he goes in and click the end meeting and then deletes the meeting from the calendar. And that will send a fully deletion to the backend server, and everything will be deleted. We're going to show that, right? So meeting expiration is 15 days, and after that time frame, everything will be deleted. Files are encrypted, so it's kind of hard to just find a file on the file share and read through PowerPoints and stuff. It's saved with a long GUID in some folder structure that you don't really have access to, and plus it's encrypted as well. A question? So it's like if you get kicked out from the meeting because of a bad network connection, and no enterprise users are logged on, then the meeting will be active for 90 minutes, and then it will shut down.
Okay, so the last enterprise users.
Yeah.
If they X'd out of.
Yeah, then that will, exactly.
Yeah, but also if you stay in a conference, for example, you start a conference and you stay there forever, that also doesn't work. If you're an enterprise user, you will be kicked out after 24 hours. So it will automatically stop. So let me switch to our machine, because so there are 2 things you can do to configure. You have the conferencing configuration. So here are some options you can set for conferencing configuration. So for example, the content grace period, 15 days. This is not only for the content, it's also for the meeting expiration. So it's the same thing. And you can also set some bandwidth policies on the app sharing service, so on the server side. But I've never done this in real life. And there are some other settings you can also do in CS meeting configuration. So for example, here you specify whether you will do the default meetings by default, yes or no, the assigned conference, who is presenter, do we need PSTN callers bypass the lobby, yes or no, all of these things. So you have two ways of configuring it. So it's the CS conferencing configuration, and you have the CS meeting configuration. So we do have some extra slides, and there was a question relating to port ranges. So is there anyone fine that we go to those slides? Great. Okay, so this piece is the port ranges. So for audio, video, and app sharing. So audio, video, and app sharing have different port ranges. So you can see on the left side, those are the client port ranges. On the right side, the server port ranges. So in red, it's audio. In blue, it's video. And green is app sharing. Of course, on the client side, we have 4 port ranges because we also have file sharing, which is not in a conference. So it's a separate thing on the client. So by default, you see that we have the 60K port range on the client side for all modalities. So they're all the same, and we will choose dynamically between ports somewhere in that range. And you see on the server side that we have the audio port range, and then on top there's the video port range, and then application sharing is actually stretching both of those port ranges. So this is configured by default, which we usually don't do in production. So, but if you want to change the media port ranges, you can do something similar like this. So we still have red, blue, green, and purple for audio, video, app sharing, and file sharing. So essentially what you should do is either configure the client port ranges within the same port range on the server side, because if you're doing quality of service, then it's kind of easy to understand that it's both, for example, it's audio in this port range, and it's not application sharing, because if you want to do it in this way, then it's like application sharing will take up somewhere those port ranges. So you should essentially, for every modality, have a different port range within the server port ranges. And of course, we don't want to have application sharing to have the default port range, because then it takes all those ports. So we usually do it like this. So we start from 40801 and go up to the port range for audio. And also that's like 8,000 ports. Then you can also set it on the client side in this port range. So important to know is that on the client side, there's a recommendation of having at least 20 ports for audio, video, and it used to be 4 for application sharing and file sharing, which now has changed. Are you aware of that? So Microsoft has changed this, and there's a networking guide which actually talks about that. So they changed it from minimum from 4 actually to 20. Because potentially you can have multiple application sharing sessions going on, or file sharing sessions, and well, they upper the recommendation anyway. It still works with 4, but now it's recommended to do 20. So,
sorry, what is the user experience if you run into, if you use up all the ports?
Well, I've seen it in production, because if you drag and drop like 5 files into your client, then it won't work. So then you will have an error, because we cannot send this information.
There's no real indication that it's due to the
No.
port.
No, fortunately not. So, and of course, on the client side, we still have the file sharing port range, which we also have to exclude from the server port ranges. So then we do something, we create them somewhere on the lower port ranges. Or you can do, obviously, also something like this. Have the client port ranges completely separate from the server port ranges. But that's something you have to decide on your own, and maybe talk to the network guys for firewall rules, all kinds of stuff like that. So that's it for server port ranges and client port ranges. Any questions? I think, what time is it?
We are kind of out.
Okay. So any questions? Yes.
In our environment, we've had some collision issues with audio when we're in a group meeting and we're on Lync audio, and then someone goes to start app sharing, the audio is getting stopped on, and we lose it for a period of time, seconds, until the app sharing can complete, and then the audio comes back. Have you seen that before?
Yeah, I think it's related to sizing and potentially also if you're using virtual infrastructure, and I don't know how big the meeting is, but if it's a big meeting, obviously if you start application sharing, it will be a lot of data, well, in the beginning, because everyone has to receive that stream. So potentially your server is running out of bandwidth. Potentially your network adapter is even full. So potentially you have to look at those things like sizing and network traffic. That's my guess. Any other questions?
Which database are the meetings saved to? Meeting information.
RTC
RTC local.
right?
Because in the DB analyzer, we connect to RTC local.
Oh yeah.
We can, maybe we can show it.
I have a comment. We just had a Lync health check from Microsoft Premier Field Engineering, and they made a recommendation if you want to be able to pull information from the meetings, archive it, because that way it's already decrypted in the database, and then you can easily pull it out rather than having to decrypt the information on the file share server. So
Yeah.
I would share that.
So you see here in the DB analyzer, we say SQL server. So this is essentially on the local server, RTC local.
Thank you. I didn't write it down.
But changes, like live changes to the meeting states, or if you upload, what was it? There are something with meetings that are saved in RTC DIN, and if you have like a pool failover, that information will not be failed over to the secondary pool. You remember on that?
Yeah, probably. You know all about primary, secondary, tertiary, that we're replicating all the information between those front-end servers, and that only the persistent data is stored in the SQL backend. Well, this is also the cached persistent data, of course, on the local front end. Because essentially when you have a large pool, you can live without SQL for a certain amount of minutes. So, but yeah, every server needs to have that information locally.
Okay, so we have a last slide here.
Wait. Okay.
And that's the buy. And thank you for coming. And answer to the buy. There you go.
Well, we have one giveaway left. So should you ask another question? So what's the default audio port range on the MCU?
49, 152,
Yeah,
57.5.
yeah, that's it. Congratulations. So and by this, thank you guys for joining.
Yeah, thank you.